So sometimes we'll have a problem like for this one, sine of 15. That's not on the unit circle, so usually we would just have to pull out our calculator. But if I rewrite that 15 as, let's say, 45 minus 30, and the reason I chose those is because those numbers, those degrees, are actually on the unit circle, and I can actually find the exact values of sine at those places. Okay, now I'm going to pull out my sine. Let's see, it's a subtraction in there, so I'll use this one. And the important thing here is, let's see, it's a subtraction, so I'm going to do a subtraction there in the middle. Okay, so I've got the sine of the first one times cosine of the second angle minus cosine of the first times sine of the second. And now I just evaluate those, just remembering my unit circle. So sine of 45 degrees, that's square root of 2 over 2. Cosine of 30, that is square root of 3 over 2. Cosine of 45, square root of 2 over 2. And sine of 30 is 1/2. And then just multiplying on the top, square root of 2 times square root of 3 would be square root of 6. And then that would be over 4. And then the second one is square root of 2 over 2. Which simplifies to square root of 6 minus square root of 2 all over 4. Okay, let's try another one. So I'm going to look at this 11 pi over 12. So that's obviously not on the unit circle. But if I think of 11 like 8 plus 3, and those are going to be twelfths, those would add together and actually be equivalent to 11 pi over 12. Okay, now I can simplify my fraction. So I've got that 8 pi over 12, that simplifies to 2 pi over 3, and 3 pi over 12, that can simplify to pi over 4. And then I'm going to use my cosine. Let's see, it's addition, so I'm going to use this one at the top, and just be on the lookout here, because with cosine it goes to, we're going to have to subtract those two expressions. All right, so we've got cosine just goes cosine, cosine, so cosine of the first, cosine of the second, then you change the operation there, and then it would be sine of the first and sine of the second. And now we just need to use our unit circle and just remember what all these evaluate to. So let's see, cosine of 2 pi over 3, that is this one right here. Cosine is the x, so that simplifies to 1/2. Cosine of pi over 4 is root 2 over 2. Okay, sine at 2 pi over 3, that is square root of 3 over 2, and sine at pi over 4 is square root of 2 over 2. And then we simplify these, so we'd get the first one would simplify down to square root of 2 over 4, and then minus square root of 6 over 4. And we could write that as square root of 2 minus square root of 6 all over 4. And there's our exact value. All right, let's find the tangent of 13 pi over 12. And yes, we could just plug this into our calculator and get an approximation, but we're being asked to find the exact value here. All right, so 13 pi over 12 is, 13 is a bigger number. So I'm going to try the addition formula for tangent. All right, let's think about how we could get 13 pi over 12. Well, 13 is the same thing as 1 plus 12, 2 plus 11, 3 plus 10. And there's lots of ways to do this. I'm going to just try that 3 pi over 12 plus 10 pi over 12. Okay, so those both add up to 13 pi over 10, which was our original problem. The reason I chose that way of doing the fractions is because 3 pi over 12, that simplifies to pi over 4, which is on the unit circle. And then 10 pi over 12, those are both even, so that simplifies down to 5 pi over 6, which is on the unit circle. Okay, so try and figure out a way to write your sum or your difference so that those fractions simplify to numbers on the unit circle. Pull out your unit circle, and we see that tangent of pi over 4 is 1, and then tangent of 5 pi over 6 is square root of 3 over 3. All right, so that's great. Now we're going to use our sum formula for tangent, and so we need to do, let's see, tangent of A, the first angle, pi over 4, plus tangent of the second angle, 5 pi over 6, all over 1 minus their product, tangent of pi over 4 times tangent of 5 pi over 6. Now we're going to plug in the values that we just found into that big fraction and start simplifying it. Okay, so tangent of pi over 4 is 1. Tangent of 5 pi over 6 is square root of 3 over 3. In our denominator, we have 1 minus tangent of pi over 4, which is 1, times tangent of 5 pi over 6, which is square root of 3 over 3. And it looks like I've got a complex fraction there. I'm going to just try and deal with the fact that I've got fractions in a fraction. I'm going to simplify that. I'm just going to clear fractions there. Distributing the 3 in the numerator, I would get 3 plus, let's see, distributing the 3 in the numerator, square root of 3 over 3 times 3. Those 3's would cancel, and I would just get the square root of 3. And in the denominator, I would get 1 times 3. So it would be 3 minus the square root of 3. And that is what's being asked for there. In this problem, we're being asked to evaluate cosine of the sum of angles A and B. So we know from the sum formula for cosine that cosine of A plus B would be the product of cosine of A times cosine of B, and then minus the sine of A times the sine of B. We're given a little bit of that information that we need to plug in. We have the fact that what's given is cosine of A is equal to 3/5, but we don't know what cosine of B is. We also don't know what sine of A or sine of B is. So we have a little bit of work to do, and we're going to use these two hints that are given. The first hint is that cosine of A is 3/5 and angle A is in quadrant 4. And the second hint is that tangent of B is negative square root of 3 and angle B is in quadrant 2. All right, let's use the first hint. Cosine of A is 3/5. And cosine is defined as x over r. And in quadrant 4, if we have an x value of 3 and an r value of 5, we can use the Pythagorean theorem to find y. And because it's given that angle A is in quadrant 4, the y value there needs to be negative. So we end up getting a y value of negative 4. Now that is great, but what we actually need is the sine of angle A. All right, well, sine is y over r, and y we just found is negative 4. R for angle A is 5. Okay, so now that gives us some information to know that sine of A is 4/5. Well, what about angle B? Luckily, we have a little bit of hints on angle B. We know that the tangent, because tangent is y over x, negative square root of 3 is the same thing as square root of 3 over negative 1. And I'm going to write it that way because in quadrant 2, the x value is negative and the y value is positive. And so now we need to find our r, use Pythagorean theorem. We'll solve for r, which in this case is 2, and then that allows us to find sine of b, which is y, and y is square root of 3 over r, which is 2. And then we need also cosine of b, which is x over r. And so that is -1/2. All right, so plugging those values in for our sine of b and cosine of b. Okay, we're going to take that information back. Cosine of b is -1/2, and sine of b is square root of 3/2. All right, and now we need to just multiply those fractions. We would get -3/10 minus a -4 square root of 3/10 minus a negative is plus, and so we end up, once we add those two fractions, getting -3 plus 4 times the square root of 3. All right, so again, what we're doing is we're using the sum formula for cosine, but we need to get ourselves set up using those hints to figure out what values for cosine of A, cosine of B, sine of A, sine of B we can plug in and use in that sum formula. Okay, here I'm supposed to prove that sine of pi plus theta is equal to the opposite of sine theta. Okay, so I'm going to use the sum formula for sine. So I have sine of the first angle times cosine of the second angle plus cosine of the first, so cosine of pi, times sine of the second. And now I'm going to evaluate my function. Sine of pi is 0, and so that's still times cosine theta, and cosine of pi is -1. Okay, so simplifying that, we would get negative sine theta, and so I just showed that the sine of pi plus theta is equal to the opposite of sine theta. And we're done.